The learning intention for this video is that we will understand how to determine whether an equilibrium will be formed in a chemical reaction using enthalpy and entropy. So essentially, we're trying to answer the question, how do we know if a chemical reaction is going to reach an equilibrium? So before we can answer that question, we do need to review our knowledge of enthalpy and entropy and the laws of thermodynamics. If you think you've already got your head around those things, then just use the chapters below and you can skip ahead to where I answer the actual question. Thermodynamics refers to the relationship between energy, usually heat energy, and the work being done. The first law of thermodynamics, also known as the law of conservation of energy, states that energy can neither be created nor destroyed. It can only be transferred or transformed. This means that energy is always conserved in a chemical reaction. This law is particularly related to the enthalpy of a system. Enthalpy refers to the heat energy a system possesses. Enthalpy change is when heat energy passes into or out of a system during a chemical reaction. A system will favour a reaction in which enthalpy decreases during a chemical reaction. The second law of thermodynamics states that when energy changes from one form to another, entropy in a closed system increases. Entropy refers to a state of disorder or randomness in the way energy is dispersed in a chemical process. It is a measure of how much the energy of molecules or atoms in a chemical process becomes spread out during a reaction. This means the more energy that is transferred by a system to its surroundings, the less organized and the more disordered the system is. A system will always favor a reaction that moves towards increasing entropy or increasing disorder. Have you ever noticed that you start the year out with a nice new science book with neat headings, color coding, and beautiful handwriting, but by the end of the year, or let's be honest, probably by the end of the term, it's really just scribbles on every page? This is an example of increasing entropy or increasing disorder. The third law of thermodynamics states that a crystalline solid at absolute zero temperature has an entropy of 0. This is because a solid in this state is the most ordered it can be. This also means that a reaction is going to favour a side that has more moles of gas. If entropy is how much the molecules are spread out and how disordered a system is, then gases are going to be more favoured over liquids and solids. Now, if we put all this together, it means there's two main factors in determining the progression of a chemical reaction. The first is that chemical reactions are going to favour a decrease in enthalpy. And the second is that chemical reactions favour an increase in entropy. This means that we can use enthalpy and entropy in order to determine the result of chemical reactions. So let's go back to our beginning question. How do we know if a chemical reaction will reach equilibrium? If we just throw certain chemicals into a closed system together, how do we know if it's actually going to reach equilibrium? Let's look at the three scenarios. So the first one, if enthalpy and entropy oppose each other, then the reaction is going to reach equilibrium. For example, if the minimum enthalpy of a chemical reaction favors the forward reaction, while the maximum entropy favors the reverse reaction, then this reaction is going to reach equilibrium. If both favor the products, then this reaction is going to go to completion. For example, if minimum enthalpy and maximum entropy both favor the forward reaction, this is going to go to completion. And the third one is that if both favor the reactants, then this reaction is not going to occur. For example, if minimum enthalpy and maximum entropy both favor the reverse reaction, the reaction will not occur. Let's look at some examples. In this reaction here, we have potassium reacting with water to produce potassium hydroxide and hydrogen gas. In this reaction, the heat is on the side of the products, showing us that it is an exothermic reaction. This means the products are favored in terms of enthalpy. The entropy also favors the products, as there are more moles of gas on the product side. Since both the enthalpy and entropy favor the products, this reaction is going to go to completion. It will not form an equilibrium. Here's our second example. This one we have sodium hydroxide and hydrogen gas reacting to form sodium as a solid and water. This reaction is endothermic, which we can see because the heat is on the reactant side of the equation. This means the reactants are favoured in terms of enthalpy. For this equation, we see that there is 1 mole of gas on the reactant side and 0 moles of gas on the product side. This means the reactant side is also favoured in terms of entropy. Since both entropy and enthalpy favour the reactant side, this process will not occur. There will be no reaction and the sodium and water will not be formed. This means if you put sodium hydroxide and hydrogen gas into a sealed container, nothing will happen. Here we have a reaction where ammonia is decomposed into nitrogen gas and hydrogen gas. This is an endothermic reaction because the heat is on the side of the reactants. As the reaction is endothermic, the reactants have minimum enthalpy, and so the reverse reaction is favoured based on enthalpy alone. The entropy of the system increases in the forward direction. We see 2 moles of gas on the left and 4 moles of gas on the right. This means the reaction will favour the products if based on entropy alone. So the enthalpy favours the reactants, entropy favours the products, and that means that this reaction will form an equilibrium. I hope this video has helped you to answer that question, how do we know if an equilibrium will be formed in a chemical reaction? If you like this video, please hit like and subscribe to my channel below.